Morning Algebra. Today we're going to be simplifying rational expressions. So let's get started. Let's recall that a rational number is just any number that can be written as a fraction. So any number that you can write as a over b, right? So you could have 1/3, or you can have x over 4, or 2x over 3. These are all different types of rational numbers, okay? And a rational expression is very similar. It is a fraction, so it is a rational expression. It has polynomials, though, in the numerator and the denominator. So, for example, you could have 1 over x, okay, because you have that denominator that has an x value, or you can have x plus 2, say, over x plus 3. You have two binomials, one in the numerator, one in the denominator. And you can have even some quadratics in here, x squared minus 5 all over x squared minus 10x plus 25. Okay, these are all examples here of rational expressions. So they're expressions that are fractions that have, notice in a rational number, you have no variables in the denominator. Okay, but if you have variables in the denominator, now it has graduated and become a rational expression. Okay, and today we're going to be simplifying those rational expressions. I want you to notice, though, we'll just make a little note here, that we are just going to assume that all values of x that make that denominator 0 are excluded. Okay, so remember that your denominator cannot be 0. You cannot divide by 0. Then it is undefined. So we're just going to pretend that all of those values have been thrown out the window. Okay, so all values of x that make the denominator 0 are excluded. So in order to study this, we're just going to exclude anything that makes the denominator 0. So for the example, in this first one, if x were to equal 0, then, x can't be 0. So 0 is thrown out of that equation. This one here, x cannot be -3, right? So we're going to throw out -3 for that problem. That's what this note means, okay? And so we have 3 steps to simplifying a rational expression. Step number 1 is going to be factor the numerator and or the denominator. So you may have to factor both pieces or one or the other, okay? So for our factoring rules, if you need to refresh yourself, then all of our factoring we studied in Chapter 9. So you can go back to your notes or go back in your textbook if you're struggling with factoring today and get a refresher from there, or reach out to me, email, call, or text. I can help you out. All right? Then we're going to divide out the common factors, or the common factor if you've got any. And the last step will be to simplify. Okay, so I wanted you to have all the rules before we get started, and now we can move on to an example. Okay, so what we're doing is we're taking these rational expressions and simplifying them down so we cannot simplify anymore. All right, let's look at this first example. 6x plus 12 divided by x plus 2. Okay, remember step 1 is going to be to factor the numerator and or the denominator. So look at this numerator portion. Can you factor anything out of 6x plus 12? Yes, the common factor here is 6. So I'll factor out this 6, and now I have x plus 2. Okay, so I'm going to factor out the 6. In the denominator, can I factor x plus 2? No, there's no common factors between x and 2. But notice why this is really nice, okay? If you recall, I'll come over here to the side, right below my face, and recall that if you have, let's say, 3 divided by 3, what does that equal? 1. And if you have x divided by x, that also equals 1. Or, remember, they will cancel each other out. So notice here how I have x plus 2 divided by x plus 2. Well, x plus 2 divided by x plus 2 is equal to 1. So now I'm just left with 6. And remember, this is equal to 1 now, so that's just 6 times 1, which leaves me with just the number 6. So we have now simplified that rational expression just to be a whole number 6, which is our final answer. Okay? Let's look at another example. All right, 2x minus 12 times x squared, divided by x squared minus 7x plus 6. Again, step 1 is going to be to factor, okay? Step 1 is to factor. In this case, we're going to be able to factor both pieces, okay? Notice here, what is your common factor here? Your common factor in the numerator is going to be 2, because I could take 2 out of 2x, and I'll be left with an x, minus 12 divided by 2 is 6, okay? In the denominator, though, notice here I have a quadratic, so this is where you need to go back to chapter 9 and refresh yourself on how to factor out quadratics. You want to look for the factors of c. Okay, so for this one, you want to find 2 factors of c that add up to b. Okay, and remember, b and c come from ax squared plus bx plus c. Okay, I believe in that chapter there was a nice summary of when to use which type of factoring, and this one's nice because notice that I don't have an a, so we can look for those factors. And I can think of 2 right away. I have here -6 and -1. When you multiply them, they're going to equal +6, but when you add -6 plus -1, you'll get -7. So this will be x minus 6 and x minus 1. Now step 2, okay, we'll come over and do step 2, is going to be to, is going to be to divide out the common factor. Okay, so the divide out, and we've already done that. Okay, your common factor here is going to be x minus 6 and x minus 6. X minus 6 divided by x minus 6 is going to be 1. So then in your last step, step number 3, is going to be simplify. Well, what are you left with? Okay, in the numerator, I'm left with a 2, and in the denominator, I'm left with x minus 1. Okay, and I cannot simplify this anymore. This is as simplified as I can be, so this here is my simplified rational expression, 2 over x minus 1. Oh, I just noticed that my face is in the way. Here we go. Okay, I hope that that has not confused you. All right, we've got 2 examples left, and I'll try to be conscious about where my camera is so that I do not cover them up. And so let's scroll on down and look at this next one. 5x minus 15 divided by 9 minus x squared. Okay, so again, make sure you want to use step 1 is you want to factor. Okay, maybe it's easiest to come across like this. We're going to factor. In the numerator, I can factor out a 5. So now I have 5 times x minus 3. Notice here in the denominator that I have the difference of 2 squareds. If you have a squared minus b squared, then that's going to be a plus b times a minus b. So in this example, my a here is 9, which the square root of 9 is 3. So now I'm going to have 3 plus the square root of x squared is x, 3 plus x, and 3 minus x. Okay. Now, in step 2, you want to factor, but this one sort of has an extra step here. So I'm going to do it like this, an extra step. And your extra step is going to be, do you need to factor out a -1? Question mark. Okay? And the answer in this case is yes, because notice here, you might be saying to yourself, well, I have an x minus 3 in the numerator, but I have a 3 minus x in the denominator. They're similar, but not the same. Okay? Notice that the x is positive in the numerator and the 3 is negative, whereas in the denominator, the 3 is positive and the x is negative. But we can fix this. Okay? So to fix this, in the numerator, you can take out divide by -1. So now I'm going to have -5, and now everything inside parentheses will change the signs. Now I'm going to have -x plus 3 on the inside. And my denominator here is going to stay the same, 3 plus x and 3 minus x. Okay? So now do you see that the relationship between -x plus 3 and 3 minus x, are they the same? Yes, they're just reversed. Okay, so -x, the x is negative, the 3 is positive, plus 3, is the same as 3, where 3 is still positive, minus x, and the x is negative. Therefore, if you divide by the same thing, they're going to divide out to be, which this is step number 2, they're going to divide out to be 1. So what do we have left now? In step 3, we're going to simplify. Okay, and in step 3, simplify. Well, what do I have left in the numerator? I have a negative 5. And what do I have left in the denominator? I have an x plus 3. And I know that it says 3 plus x, but proper math grammar is we write the variables first. So this here would be the proper final answer, negative 5 over x plus 3. Okay. And in our last example, we have a little word problem here. The baking time for bread depends in part on its size and shape. A good approximation for the baking time in minutes of a cylindrical loaf, which is just a regular loaf of bread that has a rounded top and sort of a rectangle on the bottom. You can draw it over here. So here's a cylindrical loaf, like so. Is 60 times volume divided by the surface area, or 30 RH divided by r plus h, where the radius is r and the length of h of the baked loaf are in inches. Find the baking time for a loaf that is 5 inches long and has a radius of 4 inches. Okay? And so what we want to do now is plug these values in. I have 30 times r, which r, it says the radius is 4 and that the height is 5. So 30 times 4 times 5 divided by, well, the radius again is 4 plus the height of 5. Okay, so I've been given some variables. We know what to do when we're given variables. You plug them in, and now we're going to solve. Okay, 4 times 5 is 20, so now I have 30 times 20, which 3 times 2 is 6. Add your extra zeros is 600. 4 plus 5 is 9. Now I have 600 divided by 9. You could type that into your handy-dandy calculator, and you'll get 66.6666 forever, which we know is 2/3. Okay, and so I would bake this, round your answer to the nearest minute. So if I got 66.67, then I'm going to round to the nearest minute, which is going to be approximately 67 minutes that we want to bake this loaf of bread. Okay. All right, tomorrow we're going to do our checkpoint quiz. Your checkpoint quiz is on page, well, I'll put it up tomorrow. Anyway, and then we'll have a Zoom session on Wednesday, and you'll have your quiz the day after that. So if you guys need help with any of these assignments, please get them turned in so I can review them for you. I'm going to have them all graded for tomorrow, and if you need help, send me an email, call, or text. Bye.